Hey everybody, welcome back. Today 5-8 is coming your way. We're going to be talking about scale drawings and scale models, and we're going to stay on that proportion bandwagon. Woohoo! We have proportion still yet going on today. All right, so what I want you to do is there are 4 warm-ups here, so please pause the video and answer your 4 warm-ups. Awesome. Go. All right, so as you are writing these down, you're answering these. Again, you are able to use a calculator, so I hope that these work out. All right, here we go. So we take 3x, which is 3 times 16. 3 times 16, when you multiply them together, you get 48 as your answer. 48 as your answer. Awesome. 3/4. 3/4, you're multiplying that by 16. Remember, when I'm multiplying by 16, that's the same thing as taking 3/4 times 16 over 1. We can simplify across here. I get 1, I get 4, because I can divide both of them by 4. My answer is 12. 3 times 4 is 12. We don't need the denominator of 1 because that's just an integer. Okay, then we have 10x when our x is 2/4. Do not forget, we still know how to multiply a number and a fraction like we did for 3/4 and 16. That was a lot of talking really fast. We need to multiply 10 times 2/5, which is, bam, 10 over 1 times 2 over 5. We can simplify this down. This becomes a 1. This becomes a 2. I simplified by dividing each of those by 5. My answer is 4. Then 1/4. Again, I'm multiplying when that coefficient next to the letter, they are multiplying. I'm going to multiply this by 2/5. I can once again simplify across. This becomes a 2 at the bottom. The 4 becomes a 2. The 2 becomes a 1 because I divided by 2. Multiply straight across. My answer, 1/10. Okay, 1/10. There are my answers. All right, so that's just a little warm-up to get your brain moving a little bit today. Okay, let's keep going. Hey, like I said, we will be talking about scale drawings and scale models. We're going to be making comparisons between and finding dimensions of scale drawings, models, and actual objects. So moving between the 3 things. Okay. All right, very first thing, please write down the definitions to these words of scale drawings and scales. In order for us to talk about it, we need to know what they mean. All right, so go. All right, so as you look at this, it says a 2-dimensional drawing that accurately represents an object. So a lot of times when you see scale drawings, you see things like blueprints. Blueprints of houses, blueprints of exterior designers, blueprints of interior designers when you're moving different things around. You may see blueprints of a new building being built. Okay, so these are used quite a bit. Now, your scales is what gives that ratio, again, of the dimensions in the drawing to the dimensions of the object. If you think of, for instance, a map. Okay, maps have scales. All right, like 1 inch on a map equals 250 miles. That allows us to break down 250 miles into a single inch as we look at it on a map, because we don't want to have a map that's the actual distance. Why? Because if I wanted to find the distance between here and Japan, I don't want to have to go actually walk the distance to figure that out. I want to be able to look at a map and measure and maybe find a distance similar to it. Okay? All right, so there are different scales. Of course, there's an infinite number of scales. What they do is they may compare the same unit or they may compare different units. Okay? So for instance, you could look at 1 to 20 is 1 unit to 20 units. 1 centimeter to 1 meter is 1 centimeter on the drawing is 1 meter in real life. Okay, same thing with 1/4 of an inch to 1 foot. All of these can be used. So the very first thing we have to do is the length, is the length of an object on a scale drawing is 2 centimeters. Its actual length is 8 meters. We want to find what the scale is. Now, as you look at this, the scale is going to be a ratio that allows me to put this into a proportion. Okay? So if I look at this, I know that there are 2 centimeters on the scale drawing, and that means it is equal to 8 meters in real life. When we set up a proportion like this, we set up a proportion that goes scale over actual, okay, is equal to scale over actual. All right, again, notice scales on top, actuals on bottom. So if I were to look at this, that ratio right there, 2 to 8, I look at this and I'm going to write that as a scale to actual, which it is. I'm going to write 2 centimeters over 8 meters because that's what that means. On the other side, my scale, my 1 centimeter is my scale over X amount of meters because that's what we're trying to find right here. Notice I have centimeters on top, meters on bottom on one side, centimeters on top, meters on bottom on the other side. Okay? And we solve it like we've been doing with proportions. Cross multiply, I get 2x is equal to 8. Divide by 2, x is equal to 4. Now, if you give me x is equal to 4, it is incorrect because what do I need to have? Label meters. It is 4x is 4 meters. It asks, okay, what is the scale? Okay, is the scale just 4 meters? No. The scale is 1 centimeter to 4 meters. So be careful. Make sure that you're answering your question correctly, answering the full question. So you found x, but we need to take that x and plug it back in here. Wow, look at all those arrows going everywhere. Okay, so plug it back into a scale. All right? When you look at a scale of A to B, it is read as A to B. So A colon B is read as A to B. For example, that last problem, it was 1 centimeter colon 4 meters. That means 1 centimeter to 4 meters. That means 1 centimeter on the scale means 4 meters in real life. Okay. Try this one on your own. Give it a shot. Just like the last one. So set up a proportion. The biggest thing, set up a proportion. Make sure you're writing this problem down, of course. But set up a proportion to answer this problem. Go. All right, here we go. What will this proportion look like? Well, again, we are going to use this. And if you need to write this down, write this down. It's very important. Might help. Scale over actual is equal to scale over actual. I didn't even read the problem, and I'm already on the right track with this. Okay, now I'm going to read the problem. It says the length of an object on a scale drawing is 4 centimeters, and its actual length is 12 meters. The scale is 1 centimeter to X amount of meters. What is the scale? Okay, now as you look at this, scale over actual, this first piece of information on a scale drawing. So my scale is 4 centimeters. Its actual length is 12 meters. I'm going to set that equal to 1 centimeter over X amount of meters. I want to make sure that my labels on top of centimeters line up. I put scale over actual, scale over actual. Okay? Cross multiply here. I get 4x is equal to 12. Divide by 4, divide by 4. X is equal to 3. 3 what? Meters. Put this back into a scale. I get 1 centimeter to 3 meters. Now, you may be thinking, Mr. Schumann, I knew that right off the bat. That was an easy one. Easy. Again, It may seem and may look easy, and you can do that very quickly, but I want to see this proportion. I want to see that proportion. That is important to me so that I know you can show me a proportion and create a proportion, okay? So I need to see that proportion, all right? Next. Okay, it says, under a 1,000 to 1 microscope view, an amoeba appears to have a length of 8 millimeters. What is the actual length? All right, well, again, how do we set up our proportions? On the last two problems, how did I set it up? Scale over actual is equal to scale over actual. Okay, so as I'm setting this up, 1,000 to 1, that means you're zooming in 1,000 times. Okay, zooming in 1,000 times to what a normal person zooms in. So this right here, this scale, or this that ratio right there, that scale, is actually 1,000 is our scale, 1 is our actual. We go in 1,000 times more than the average eye. Okay, then it says an amoeba appears to have a length of 8 millimeters. Now, what would that be? Is the actual length 8 millimeters? No, it's not. We're trying to find the actual length. Okay, it tells me right there, right off the bat, what is the actual length? I can put my X down right away. My actual length is not 8 millimeters. My scale length is 8 millimeters. If you look straight across, at 1,000 times, I find my amoeba is 8 millimeters. Now what I'm going to do is just cross multiply and solve. 1,000x is equal to 8. Divide by 1,000. Divide by 1,000. X is equal to 0.008 millimeters. Am I done? Yes, I am done, because it asks me to find the actual length, not the scale. I don't have to plug anything back into the scale because it already gave me the scale of 1,000 to 1. So I don't need to do anything else besides just solve for x. Just solving for x. That's x in Spanish, in case you were wondering. All right, it's your turn. I've been talking so much. Now it's time for you to try a problem. So pause the video, write the problem down, go. Oh, before you go, and try it. Now go. All right, let's see how you did. It says, under a 10,000 to 1 microscope view, a fiber appears to have a length of 1 millimeter. 1 millimeter. What is its actual length? Okay, it's asking me what is the actual length. So again, scale over actual equals scale over actual. The average person sees, the microscope allows us to see 10,000 the normal view of one person, which is equal to 1 millimeter over x millimeters. Cross multiply, I get 10,000. X equals 1 millimeter. Divide by 10,000. And my answer is x equals 0.0001 millimeter. Again, I'm done. I'm finding the actual length. If you were to look at that, fiber without a microscope, it would have a length of 10,000th of a millimeter. 10,000th of a millimeter. Yeah, that's small. All right? Next definition is scale model. Scale model. Okay, so pause the video, write this down, and we will talk. All right, so it says a scale model is a three-dimensional model that accurately represents a solid object. If you look at model airplanes, model boats, model cars, okay, these can be scale models. They have a certain ratio. They are identical. Their sizes are different, but the actual shape is the same. I had this awesome 1996 Ford Taurus forest green model car when I was younger. Oh man, that thing was sweet. Okay, that was a scale model back in 1996. Okay, but it still represented the real 1996 Ford Taurus, which everybody wanted, especially in that forest green color. Okay, that was rare. I don't know if it was actually rare, but okay. Moving on. So this says a model of a 27-foot tall house was made using a scale of 2 inches to 3 feet. What is the height of the model? Okay, what we have to do is we're going to set this up into a proportion. Okay, again, I'm going to use that same idea, the same idea of scale over actual is equal to scale over actual. Okay, the tricky part is plugging things in where I want to plug in. All right, so I will get my scale right here is 2 inches to 3 feet. 2 inches over 3 feet. Okay, I'm going to set that equal to, again, the scale is 2 inches to 3 feet. This is the height of the model. 2 inches on the model is equal to 3 feet in real life. A model of a 27-foot tall house. That means the house is actually 27 feet. So my 27 goes on bottom. My X goes on top. Notice again, my labels here of feet and feet are on the same line. Inches, and this will be inches, are on the same line. Okay? So we have similar labels on both sides, but also scale over actual is equal to scale over actual. We're going to cross multiply here. I get 54 is equal to 3x. Divide by 3 on both sides. 18 is equal to x. What's my label on that 18? It's 18 inches. Okay? Again, we're setting up a proportion and solving. Setting up the proportion and solving. All right? Let's try one last problem of the day. See if you can come up with this proportion. And go. All right. It says a model of a 24-foot tall bridge was made using a scale of 4 inches to 2 feet. Very first thing, okay, just like the previous problems, I'm going to set up, I have my scale. I'm sure you're sick of hearing it, but I'm going to say it again. Scale over actual is equal to scale over actual. First person to come up and tell me that tomorrow morning, I'll give you a nice little piece of candy. Tell me scale over actual is equal to scale over actual, and you can tell me that right away in the morning when you get here or when I get here. Okay? Okay, for a piece of candy. Then, it is 4 inches is my scale, 2 feet is my actual. Set that equal to, I don't know what my scale is, that's what I'm trying to find. What my scale height of the model is, and my actual height is 24. Okay? I'm going to cross multiply. I get 96. Cross multiply equals 2x. Divide by 2. Divide by 2. X is going to be equal to 48. Am I done? No. No. I need 48 inches. Don't forget my inches there. That's very, very, very important. Very, very, very important. Okay? Don't forget your labels. All right. I hope you enjoyed this video on 5/8 scale drawings and scale models. I will see you later. Have a great day. Bye.